Hello dear students, let's see this a bit controversial question of IIT-JEE Advanced 2016 from Geometrical Optics. It was a bit controversial because by conventional method students were not getting any correct option. So how should a student proceed for this question? And first of all, let's look for the reason for not getting answer. What is the tool for a student at IIT-JEE level for this question? Because we are taught to do the para-axial approximation. All the formula are for the para-axial approximation. We have mirror formula, we have lens formula. They are valid only for the para-axial approximation. Para-axial approximation means the angle of incidence are very small. But you can see here that after reflection from the lens, the ray falling on the mirror and the mirror principal axis is rotated by 30 degree. So angle of incidence at the mirror is 30 degree for the ray going from the optical center of the lens and then falling onto the mirror. So 30 degree is a big angle that is nowhere near the para-axial approximation. So we should not expect the lens formula, mirror formula to work here. So but then what are the tools for a student at this level, because we don't have any other formula other than the para-axial formula. So to solve this, we will adopt two approaches. One approach would be first principle approach, and still we'll apply the para-axial formula for the mirror and see how close we can reach to the given option, and then we'll choose the best option among the four options. It was a straight objective question, so only one option can be correct. So let's go ahead for this very beautiful question on geometrical optics. So here is the diagram of the question. This is a convex lens of focal length 30 cm. This is a convex mirror of ROC 100 cm. So its focal length is 50 cm. A point object is placed here. With respect to this coordinate system, the origin of the coordinate system is at the optical center of the lens, and this is a y-axis. And you can see that the principal axis of the mirror is tilted at an angle 30 degree to the optical axis of the principal axis of the lens. So we have to find the coordinates of the image, final image, after refraction from the lens and then reflection from the mirror. So for the image formation, I will treat this as a point object, and let's go ahead first the conventional way. So first of all, the refraction from the lens. For the refraction from lens, we'll find the position of the image. So we'll use the equation 1 by v minus 1 by u is equal to 1 by f. So 1 by v will be f is equal to 30 and plus 1 by u would be minus 50, and u have taken on this side, so that will be minus 50, and we can take 150 LCM, 5 minus 3, so that would be 2 by 150. So we get the position of image, 2 by 150, 1 by 75, so v would be 75 centimeter positive, mean to the right of the optical center. So its point image. Now just when we take an image of one optical system, we should forget the presence of the other optical system, and the image of this will act as an object of this. So this is placed on the principal axis, so image will be formed on the principal axis. So the image for this object from refraction from this lens will be formed somewhere here, that let me call that I1. And 75 centimeter to the right of this is already 50 centimeter, and then so this length would be from here, that would be 25 centimeter, and this angle is also 30 centimeter. For the reflection from the mirror, the x-axis would be this thing, y-axis would be this thing. Let me write this by x dash axis, and this is the y dash axis. And if I draw perpendicular from here, so that is 75, so this length would be 25, this length would be 25 cos 30, mean 25 root 3 by 2, and this length would be obviously 25 sine 30 mean 25 by 2. So x coordinate of the object, this is the x coordinate of the object with respect to this coordinate system, and x coordinate of the object is called the u. So for the reflection from mirror, we have u is equal to 25 root 3 by 2, and height of object is h1. h1 is equal to 25 by 2, and we can calculate mt, the transverse magnification for this position of object. Suppose transverse magnification is mt, I'll find the value of mt at the last moment. So transverse magnification is mt, so v will be what? V will be minus mt into u. And we know that for the virtual object, from a convex mirror, the image is real. So image will be formed on this side. So the image V will be positive. V will be, sorry, negative. So that will come out to be MT will be positive. MT will be positive mean the image will be erect. We can get from the value also. I'll get the value also. MT will be positive. So V will be negative. So image will be formed here. So I'm just writing the value magnitude of the V. So suppose the x coordinate of image is somewhere here, and this distance is from here. That distance will be mt into u, and height would be how much? Height of the image will be mt times of h1, and everything we are looking with respect to this principal axis. So the image would be from here at a height, this would be mt into h1, and obviously this angle would be 90 degree, and we have to find the coordinates of this point. So what we can do, if I make this line, so this height would be, this length would be how much? This length would be from the Pythagoras theorem, mt into square root of u square plus h1 square. All right. So now what we can do, one more thing. Now coming to the conventional logic, I want to take, we know that we are taking approximation that there are no spherical aberration, what does that mean? If there is no aberration, so for the all set of reflected or refracted ray, they meet at the same point. So if the all set of reflected rays meet at the same point, so I can take one ray, all other rays would be meeting at that point only. So I am taking that one ray which is passing through the optical center. After refraction, it will go undeviated, and now it is falling on the mirror at the pole. This is the principal axis. Principal axis is a normal, so angle of incidence is a 30 degree. So reflected ray will go like this. This is the reflected ray, and the angle of reflection will be 30 degree also. So the image has to form on this line. So this is the final image. So that we have got to know that image will be formed on this line at an angle 60 degree from this line. So that will make our life easy. So if this angle is 60 degree, so now from here what we can do, the coordinates, this length we know. So this length would be, whatever is this length, let me call this, I'll put the value letter. Suppose this length is say a, so that would be a cos 60, and this will be a sin 60, and this length is 50, so x coordinate is 50 minus a cos 60, and the y coordinate is a sin 60 only. So the coordinates of image are 50 minus a cos 60 mean a by 2. All right, and y coordinates are, y coordinate is this is y coordinate, that is a sin 60. A sin 60 is root 3 a by 2, and a is this mt, mt will calculate later. But I want to get a relationship between x and y independent of a, so that we can check from the option which of the option are satisfying this finding. So what I can write 50 here, that can be written as 50 minus x is equal to a by 2, and this can be written as the same thing, y is equal to root 3 a by 2. So y is actually root 3, a by 2 is 50 minus x. So I'll satisfy all the four options one by one and see which of the four options are satisfying. This is actually the equation of the line of the reflected ray. The reflected ray has this line equation. So option A is, in the option A, x is equal to 125 by 3. So if I put 125 by 3, so I will get y is equal to root 3 into 50 minus 125 by 3. So y will become root 3 into 150 by 3, that is a 150 minus 125 by 3, so that will be 25 by 3. So that would be how much? 25 by root 3. So option A is satisfying this finding. So basically that point is lying on this image, that point is lying on this line. And obviously option C will not satisfy this, it is looking clearly. Option B, if we see, option B, x is equal to 50 minus 25 root 3. So if we put here, y will be root 3 into 50 minus x. So 50 minus x will become 25 root 3, and that will become 75, and that is 25. So this is not satisfying. C is not satisfying. Let me check option D. So option D is x is equal to 25. So putting into this, so that will immediately become, y will become 25 root 3. So two options are satisfying A and D, but only one option is correct. So which of the option is correct, and that we will use this finding. So this is the summary of all the things that we obtained, and we have to check which of these two correct. So first let me find empty, and then from empty we'll get A, and then from A we'll get x and y. Only either x or y will be sufficient, and we'll see which of these two is correct. So for the mirror, we know that empty is equal to f upon f minus u. So f is 50, and u is how much? U is 25 root 3 by 2. So 50 minus 25 root 3 by 2, and yeah, so that would be how much? 100, so that would be 4 upon 4 minus root 3, that is empty. And u1 and h1, u and h1, and you see one thing, this is u and this is h1, right? This is u and this is h1. U square plus h1 square is this square, and this is actually 25 centimeters, so this is 25, this thing is 25. So A is 25 into 400 divide by 4 minus root 3. So I am checking the simpler one. Suppose I am checking the y. So y should be root 3 by 2 into A, which is 100 divide by 4 minus root 3. So that would be root 3 into 50 by 4 minus root 3. So I am calculating this by calculator, and let's see how much I will get. So I am getting this thing. So this thing 22.04, whatever inside the bracket, and if I compare the y coordinate of this and this is root 3 into 25. This 25 by root 3 we can write 25 by root 3 as a 25 by 3 into root 3. 25 by 3 is the universal gas constant 8.31. So this is 8.31 into root 3. So here y is equal to 22.04 root 3 from this our calculation from the mirror equation, and the two option, this option is 8.31 root 3 and this option is 25 root 3. So our answer is very close to this answer, so we will take this answer D. So the correct answer for this extraordinary question is 25, 25 root 3. Thank you.